Hello, today, this is the third video about the operating systems. I want to talk about REST conditional lock. Last time, I talked about program, process, thread, scheduling, and context switching. So let me summarize it again. A program is code that is not loading yet. A process is a program that is currently running. And a thread is the actual flow of execution inside a process. The operating system shares a CPU time between many tasks, so it looks like many programs are running at the same time. But here, there's some problem. It's good that many processes on a thread can run together, but what if they try to use the same resource at the same time? For example, what if they try to access the same variable, the same file, the same memory space, the same database value, or the same device at the same time? At this point, just sharing the CPU is not enough. If multiple execution flows touch the same resource at the same time, the resource can become strange and incorrect. This is today's main idea. When multiple threads use the same resource at the same time, the resource can change depending on the execution order. We can say that the problem is a race condition, and one common way to prevent this problem is using a lock. Let me use the kitchen analogy again. Until the last video, I imagined the one chef handling many orders by switching between them. The chef works on the pasta for a little bit, then the salad for a little bit, then steak for a little bit. Because of this fast switching, it looks like many orders are being handled at the same time. But now, let's imagine that there are multiple chefs in the kitchen. If there are multiple chefs, the kitchen may work faster. One chef can make pasta, another chef can make salad, another chef can cook steak. From the outside, it looks much more efficient, but problem can also happen. What if multiple chefs try to grab the same knife at the same time? What if they try to use the same pan at the same time? What if they try to modify the same sauce container? What if they try to mark the same order sheets at the same time? At this point, and the kitchen can become more chaotic. A similar problem happens in operating systems. When multiple threads run at the same time, there may be no problem if the workflows are completely separated. But if they share the same data, the situation changes. If they read the same data, modify the same data, and save the same data at the same time, we may get a result that we didn't expect. First of all, let's look at the idea of shared resource. A shared resource means a resource that is used by multiple processors or threads. For example, it can be the same variable, the same file, the same memory space, the same database value, the same printer, or the same network connection. But there is no rule, and everyone uses them at the same time. Problems can happen. Let's look at a simple example. Imagine that a bank account balance is $100, and two threads try to deposit $10 at the same time. Normally, 100 plus 10 plus 10 should become 120. So the final balance should be $120. But in reality, something like this can happen. Thread A reaches the balance, so the balance is 100. Almost the same time, thread B also reaches the balance, so it's also 100. Now, thread A calculates 100 plus 10, so it gets 110. Thread B also calculates 100 plus 10, so it also gets 110. Then thread A saves 110 into balance. After that, thread B also saved 110 into balance. Then the final results become 110. It's not 120. Clearly, two deposits happened, but one update disappeared. Why does it happen? The problem is that two threads with the same value at the same time calculated separately, and they override each other's results. From the computer's point of view, it can be divided into multiple steps. First, read the balance value. Second, add 10 to that value, sort, save the result back to the balance. So even if the code looks like one line, it may actually be executed in several smaller steps. But if another thread comes in the middle of these steps, the results can become incorrect. This is called a race condition. Race condition is a problem where multiple threads or processes access the same shared resource, and the final result depends on the timing or execution order. In simple terms, the problem may work sometimes, but it may fail when the timing changes. That's why race condition is dangerous. If a bug happens the same way every time, it's easier to find. But a race condition may not happen every time. Sometimes the result is correct, sometimes the result is wrong, and sometimes when we learn the same program again, the problem disappears. So race conditions are difficult to debug. Now the important question is this: how can you prevent multiple threads from changing the same data at the same time? To solve this problem, we need to protect the part of the code where the shared resource is accessed. So we can say that this protected part is critical section. A critical section is a part of code where the shared resource is read, modified, or saved. If two threads enter this section at the same time, the results can become long. So the rule is simple. Only one thread should enter the critical section at a time. If one thread is already inside, the other thread must be waiting. When the first thread finishes, the next thread can enter. This idea is called synchronization. Synchronization means controlling the order of execution so that multiple threads can safely use shared resources. It does not mean stopping concurrency completely. Threads can still run at the same time, but when they access important shared data, they must follow a safe order. So one common way to solve this problem is using a lock. A lock is a tool that allows only one thread to enter the critical section at a time. A basic flow is like this. First, a thread gets the lock. Second, it enters the critical section. Third, it uses the shared resource. Fourth, it releases the lock after the work is done. After the lock is released, another thread can get the lock and enter. So a lock works like permission. If a thread has a lock, it can access the shared resource. If it does not have the lock, it must wait. As you can see, it's kind of simple way. Let's go back to the bank account example. If a thread A gets the lock first, thread B cannot enter the balance update section yet. Thread A raise the balance, add $10 and save the results. Then thread A release the lock. After that, thread B gets the lock. Thread B raises the updated balance, 110, adds the $10, and save the results. Now the final balance becomes $120. That's why locks are useful. They prevent multiple threads from modifying the same shared resource at the same time. And there's a common type of lock. It's mutex. Mutex is short for mutual exclusion. Mutual exclusion means only one thread is allowed to enter a certain section at a time. The main idea is simple. Only one thread can enter the critical section at a time. If one thread is using the shared resource, other threads must wait. But locks are not perfect. They solve one problem, but they can also create new problems if you use them incorrectly. For example, too many threads are waiting for the lock, then the program can become slow. And also, if a thread gets the lock but never releases it, other threads may wait forever. And if a program uses multiple locks, an even bigger problem can happen. So the problem is a deadlock. For example, thread A has lock 1 and is waiting for lock 2. Thread B has lock 2 and is waiting for the lock 1. Thread A cannot continue because it needs the lock 2. Thread B cannot continue because in this lock one, both threads are waiting for each other, so nothing moves forward. And now we'll talk about deadlock in more detail in the next video. For today, the important point is like this. When multiple threads run at the same time, speed is not the only problem. Safety is also important. If multiple threads access the same shared resource without rules, the results can become incorrect. This problem is race condition. To prevent it, we protect important code sections as critical sections. Synchronization is the idea of controlling execution order, so shared resources can be used safely. And lock or mutex is one common way to allow only one thread into the critical section at a time. Today, I wanted to organize the race condition and the lock. If I got something wrong, please feel free to let me know in the comments. And I really appreciate you watching this video until the end. Thank you. Bye bye.